Hey, g'day, it's Prezant. Thanks for stopping by. Now I'm working on Threadexpress version 3 today. This is episode 6. There is a playlist. The link is up there now. You know what to do. And if you're unfamiliar with Threadexpress, it's a thread milling attachment that you can build in a home workshop. It allows you to cut both metric and imperial threads, internal and external. And there is a range of pitches that you can cut with this machine. And the cutting process is carried out with a simple shop-made fly cutter. So you don't need a lot of expensive tooling once you have Threadexpress built. Now in this episode I want to get on and make a part called the main slide plate. Now this is a wooden mock-up. I did actually make a mock-up of the entire build just so I could actually see how it operated and check for any errors in the drawings that I've made for this device. And I want to turn this wooden part into aluminium parts today. Now a lot of the other parts of Threadexpress are fairly straightforward. This is one example here. This is called the transfer plate. As you can see there, it's just a profile milled into the stock, a couple of holes drilled in it and so on. So I'm not going to dwell too long on those parts. I'll just go ahead and make them. I'll show you as I get them completed, but because they're fairly basic, I don't think it's worth spending a lot of time showing you how they're made. But let's have a closer look at this part and I'll show you the stock that I've cut out for all of the rest of the build. And we'll go from there. This wooden mock-up here shows you 4 separate parts of this assembly that I want to try to do today. So this piece on top here is called the main base plate. This larger piece underneath that is called the main slide plate. And if I turn that over, you'll see that there are 2 stepped guides, and that allows the main slide plate to do its thing, which is to slide backwards and forwards. This casting here, which I've machined in episode 1, is used to attach all of this to the back of your milling machine table, and its job is to allow all of this assembly to be tilted, so it can be tilted over to the helix angle of the thread that you want to cut. So typically it's between like half a degree up to maybe 1.5 degrees depending on the pitch, but it's these wooden parts that I want to get made today. Now all of the stock that I've got for this was in much larger pieces and it had to be cut to that profile that you can see there. Now I have 3 different saws for cutting up this stock. Now one of them is a very large horizontal bandsaw, and I did a fair bit with that, but unfortunately some bearings failed on it and I just had to stop using it. I was currently dismantled waiting for repairs, and I had to then use my smaller horizontal bandsaw, which sort of works. It's got limited capacity, but I was able to get it to cut up some of the other pieces of stock. But this particular piece here, and also these guides, these linear guides here, they had to be cut up on my little vertical bandsaw. Now, this is a repurposed wood cutting bandsaw. I converted it to metal cutting, and it does a reasonably good job, but man, it's slow. These took I think probably 20 minutes each to cut. But I got it done, and there's really no other way I could have done that except maybe a hacksaw. So what we're going to do is we're going to get on and make these parts. Now you're probably looking at this and saying, well hang on, why doesn't this have any dovetails? Surely this should be a dovetail assembly. And the original version made by Cliff Hall in New Zealand did have dovetails, but we decided that having this style of linear guide was probably more accessible for people with just a vertical milling machine. You don't need to buy any special cutters to do this, but it does mean that you've got to be a little bit careful with the dimensions over this section of this stepped part here. Now, as a last resort, if you machine this up and it's too loose, you can shim it, and there is some movement, some adjustment available on these guides here. You can move one of them inwards to make the fit tighter, but if you get problems with these 2 parts in the vertical measurement down here, you're going to have to either remachine it, make the step deeper, or use a shim. Alrighty, let's go to the mill, see how we get on. This main slide plate is the biggest single part of Threadexpress, so this piece of aluminium has to finish at 325 millimeters long, 150 millimeters wide. Needs to have at least 1 flat surface, preferably 2, and there will be a long rebate step machined into the 2 long edges. Now at present it's about 2 millimeters oversized in the length and the width, And I've run an indicator along the length there, and it's, you know, within a couple of hundredths of a millimetre. But if we run the indicator across the width, you'll see that it rises in the centre and then drops back again toward the outer edges. And if you put a steel rule across there and rub that on that surface, you can see that it does have a crown in the centre. So there's the scratch mark just there. So it does need to be decked off, and I'll do that with a fly cutter. Now I've flipped this jaw of the vise onto the back of the moving jaw, and it's only gripping by about 6 millimeters, but I think it's going to be tight enough. So I'm just going to take very light cuts on the ends first, bring that back to length, and then I'll work on these two outer edges, and then we'll try the fly cutter across the top. Okay, according to my steel rule, that's correct at 325. I don't have any other measuring equipment that can go to that length. But this is probably a non-critical dimension anyway, but it's nice to get it. Now I've decided I'm going to fly cut the top off this next, and then I'm going to machine the plate to width. And I think the wisest solution here is to machine that 10mm by 10mm step in this setup. And that way everything to that point is square to each other and parallel and so on. So I was originally going to flip it over later on and put it straight on the table of the mill and cut the 10 by 10 rebate from the unmachined side, the underside. But in hindsight, I think it's better to do it all in this one setup. So I'll get set up with the fly cutter and we'll do that, and then I can accurately touch off and machine to 10mm depth, 10mm width. We'll get all of that sorted in this setup. I'm ready to start fly cutting this now, and just to be sure that nothing tips in the vise under the cutting forces, I put a machinist jack underneath this end here. I'll do the same at the other end with this one here. But I just thought I'd show you these. These are made of steel and they've been parkerized, and the thing I love about parkerizing, it gives you that beautiful black finish. And these have been sitting in my cupboard and they never ever rusted in the last 2 years. And I made a full set of these. This is the tiniest one here, and I've got a much bigger one, but yeah, they come in handy. But yeah, parkerizing is great. Well, there it is after the first pass. You can see what I mean about the surface that I had not being flat. So there's an edge that runs along here. You'll also notice there's a hard edge just there. And just bear in mind this milling machine is over 50 years old, and it does have some wear in the y-axis. And what happens as you traverse the cutter from one side to the other, there's some change in the angular positioning of the stock just because of that curvature in the y-axis. Nothing I can do about it, just going to have to live with it, but I'll take another pass now and try and get down to a flat-ish sort of surface. Alright, that's done now. It didn't quite clean up on this back edge, but that doesn't matter. That's going to go away when we do the 10 by 10 rebate. And that little step there now, I know what that is. That's the head not being trammed in the nod direction. So I could fix it, but I'm too lazy. I think it'll be fine. Okay, I've only used a single strap clamp down this end. I think that's going to be sufficient, and I ran a dial indicator back over this surface to make sure nothing tipped or moved when I tightened up this clamp, so it's all good now. So I'm going to run this 20mm high-speed steel end mill down this front face here just above the vice jaw, and then I'll use touch DRO to offset to the back face, do that one to bring this to the correct width, then we can do the 10x10 rebate. Okay, that takes care of that front edge. I'm going to offset to do the back now, and I won't show you that, you won't see much anyway. And then we'll come back and we'll start doing the rebate. Okay, I just finished that front step down, and that's completed to size. And what I need to do now is drill 3 holes in this plate, and then later on it's got to be flipped over, and I've got to machine off that step there and drill 2 holes from the back that need to be counterbored. But I must say I'm really impressed with this cutter. I bought this on AliExpress, and I think it costs around about $28 delivered. And I didn't expect much, but it's performed perfectly. And when you think about the Chinese market and how manufacturing is developed in China, it's certainly improving. It's I think the industry is maturing, but can't get over the price and the value for a cutter like that. Okay, I'll set up and drill these holes. Those 3 holes there are all going to be drilled and tapped for M10, and they have to line up with the center hole here and the 2 slots here. So this will allow the whole Threadexpress headstock to tilt over to the helix angle of the thread that you want to cut. So I just put that on there just as a bit of a sanity check. Just looking down inside there, it all seems to line up. So I'll go ahead and drill those and tap them. Okay, that's done. I'll take this out now, flip it over. Got a bit of machining to do on the other side, 2 more holes to drill, and then this part's done. Flip this main slide plate over in the vise, and I machined off the excess material from this edge here, so when I did it from the other side it was gripped in the vise by that part and I couldn't quite clean it up. So I've just side milled that and got that surface flush now, or relatively flush. Might need a bit of draw filing to finish. And then I started to fly cut the surface here. Now the goal was to make sure that these steps are the same thickness all the way along. So on my mock-up here, you can see that we've got this rebate, or this step, which is now underneath, and I need to be sure that this thickness here is as close to 15mm as I can get it. Now I got part way through the fly cutting process and started checking with the micrometer. At this end I got 14.96, meant to be 15, so about a thou under, and it wasn't cleaning up. At this end here we're 15.06, so it was 0.1 of a millimeter thicker at this end, and the same at the back. It was 0.1 thicker at this end here. So what I've done is I've shimmed it and tapped it in, and I've checked it with the indicator. At this end now we're getting that 0.1mm rise toward this end. So I'll go ahead and fly cut that now, and then that part should be finished except for 2 more holes, which I'll do off camera. Machining this main base plate was a bit of a challenge. The dimensions exceed the overall wire travel on my mill. So what I'm doing here is just bolting the part down directly to the table and machining the back edge. Then I'm setting it back up again on parallels and checking with the dial test indicator to make sure it's still running parallel to that previous cut. Now I can machine the perpendicular edge at what will be the bottom of the plate. And this ensures that I get that accurate 90-degree angle. Next part is reset and put back up on parallels, and I'm machining some of the important hole features in the part. Now this large diameter that I'm drilling here now is bored out to 26 diameter at both ends of what will be a slot. So after boring we can switch back to milling and just simply hog out the rest of the material between those two circular bored ends. Now this slot is actually just a clearance slot. Doesn't need to be absolutely dimensionally accurate, but I'm using touch DRO to keep track of the hole centers and also the width of the slot. And this is the finished pass. That takes care of all of the features except for this cutout here, which is in line with the slot, and the two 45-degree angles on the ends of the plate, but I'm going to have to reposition everything to do that. And if you're wondering how I kept track of this slot, I used touch DRO to mark out the two centers. Then I drilled through and then used the boring head to open these at 26 diameter. I've still got the center points marked in touch DRO, so it was just a matter then of working sideways with this 16mm end mill, 5mm either side of center, and that gave me the 26 wide slot stopping at the exact centers that was set up in touch DRO. Okay, so I'm going to reposition this now and do those other features. There's a lot of holes need to be drilled in this too, but we'll do that later. Late yesterday afternoon I drilled out and bored this hole here, and that hole and this slot provide clearance for a transverse spacer. And what I need to do now is machine away the stock here. Now on my wooden mock-up you can see that section very clearly. So I'm still centered over the center of the bore there. So I'll put my end mill in, and using touch DRO I can easily cut out that corner. But this is where having a wooden mock-up is really essential for me anyway. I can easily get disoriented when I put a piece of stock on the table, especially if it's not symmetrical in any of the planes. And you can easily get mixed up and sort of machine away the wrong part or drill a hole in the wrong position. So physical mock-ups for me are just a way of idiot-proofing the whole process. I just hit the corner of my parallel. Oh, you idiot. Yeah, I didn't see that from where I was standing. Anyway. Alright, that sounded worse than it actually was. There's a little tiny sort of nick on that corner there. But yeah, don't try and tell me you haven't done it. I'm just getting ready to machine the rebates in these guide rails. Now, this stock was rough cut on the bandsaw, and then it was machined to overall dimensions using a combination of fly cutting. There was also some side milling to bring the plates to the correct length, and also some face milling with a large diameter end mill. Now there are a lot of fastener holes already drilled in these parts here. Now these are for M6 socket head cap screws. The hole centers were set out in touch DRO, and I just drilled through and then opened up for the heads of the screws with a counterbore. Now there is also are also two holes for 5mm dowel pins. Now these holes at present are drilled undersize, and they will be opened up and reamed when this part has been attached to the main base plate and everything's aligned. So I'll just drill through, finish reaming, and then I can insert the dowel pins. This hole here is for a locking screw. I'll use something like a kip handle to lock the headstock in place for certain operations, which we'll talk about later. Now on the other one, these holes are slotted. There's a 2mm offset, and this allows for some adjustment. So when I put the head of the screw in there, you can see that we can slide the screw 2mm either side of center, and this will give me some lateral motions and movement so I can adjust the fit. So these holes weren't really counterbored, they were milled with a 12mm end mill, offset 2mm and plunged down again, and then the hole for the screw shank was actually drilled with 6mm drill bit, and then it was offset using 6mm end mill. So that one there is shorter, as you can see, and what I've done is I've laid out some lines there. This is just so that I don't stupidly mill something in the correct or incorrect orientation. So this is just a sanity check for me, and you can sort of see how that works there. So there's the step in the guide, and that allows that to slide up and down on this main slide plate. Now, even though I was really careful when I milled the matching recess in this part here, there were some differences in the thickness of those rails on these edges here. So at this end I got 14.94 and 14.93 at this end. So 10 microns difference in terms of being out of parallel. On this side I got 14.97 and 14.99, so about 20 microns there. Now that's less than a thou, about half a thou, so I'm not too bothered about that. And the thing is that my milling machine is old. It's never going to produce super accurate depths when you're milling quite large recesses like that. So on the matching rails, what I'm going to do is this one is going to be milled at 14.95 deep, and that's going to give clearance for 14.94. And on this side it's going to be exactly 15. Once again, it'll give me roughly 10 microns of clearance. Alrighty, so I'm going to go and get set up and we'll do that, and then I think we're going to finish up for today. Alright, this is the part that I've been putting off. I need to be very careful about the depth of cut that I do here, which needs to be 14.95. So I've set the material up in the vise, I've run an indicator across the top of that to ensure that it's level, and I'm going to hog out most of the material to within about 0.2 of a millimetre of finished size, and then I'm going to start checking with the micrometer. So a lot of material to come out. I'll just get started and I'll bring it back when I'm nearly done. My DRO says we're at 14.53mm deep here, and I've deburred this edge, and with my depth micrometer we're at 14.56, so about 0.03 out from the DRO. So I'm going to take another light pass and then a finish pass. The finish pass probably only going to be about 0.03mm deep. Let's see how close we can get. Now, I keep seeing chips as it's coming back to the start position, so it must be cutting something on the way back. But we're still about 1/100th of a millimetre off our finished dimension. But I'll measure this again. We must be really close. If I put these two surfaces together, I can just feel this one higher than this one behind it, and we want it to be the other way around. So just by feeling that, I reckon I'm within about 20 microns, and that's how deep I'll go on the next pass, and I think we've got it. Okay, that was the last pass. I used a bigger diameter and a sharper cutter. I think the other one I was using was the one I hit the parallel with, and it probably knocked a corner off it. But that surface finish is really nice. So I'm going to take this out now and assemble it. I'll do the other one of these off camera, and we'll just see how everything fits. Now I've assembled this. This is the shorter of the two-step guides, and I did this one off camera. Now this is the one that has the slots, so that you can get some sideways adjustment to close up the clearance between the width of this step here. Now at the moment this one's locked down tight, but this one here is just nipped up but not anchored down really hard. And you can see that it does slide, and there's no play in it, which is a good thing. But if I lock these 3 socket head cap screws down tight, it's not going to move. So that now is solid. So is that a bad thing? Well, yes and no. It's easy to fix, more so than if it was the other way around. If it was too loose, that was going to be a problem. So there are a couple of options. Now one of them is to put in some jacking screws. So if I put in, say, 4 socket head grub screws there, then I can wind those socket head grub screws in and jack some space in between the step guide and the plate behind it. And once you get the clearance right, you lock everything down and it shouldn't move again. The other option is to put a metal filled epoxy in between these two surfaces here, and you can nip everything up tight, get the clearances right, let the epoxy set, and then you've got sort of a custom made shim that goes between those two surfaces. And that's probably what I'll do, because I do have some of that metal filled epoxy paste. Now I am going to anodize these two step guides. The reason for that is that the anodizing gives us a harder surface finish and less prone to wear. The anodizing also holds an oil film better than just the polished 6061 aluminium. So these are small enough to fit in my anodizing tank, so that's what I'll do. Everything else would just stay with the raw finish. Now I'm going to turn this over and show you on the other side what I've done, and we'll talk about some of the parts still to come up, and then I think that's it. Now off camera I made these two spaces here. They're a very straightforward part. These are just mild steel. They've got integrated dowels that fit into counterbores in the main slide plate, and they will also fit into counterbores in this part here. This is the wooden mock-up, and they will just slip over those dowels and they bolted down with a 10mm bolt. Now this is the stock that I'll be using to make that part from. This is a very straightforward part. I'll probably do this on my CNC milling machine, and that will have a couple of spaces that will be bolted down. So they will go on there like that. These are actually finished. These have got all of the holes drilled in them for fastening. And then on top of that we got this part here. Now this has already been milled to shape, so it's accurate around the profile, but it needs to have some other features. There'll be a long slot here, and there'll be another transverse slot underneath, and that will engage on 2 steel keys that go on this part here. So they are all of the big flat parts that are nearly done, and then after that there's a lot of stuff that needs to go inside here. So there's the nut, there's the yoke, there's the ratio arm, all that sort of stuff. But I feel like I'm getting somewhere now. I feel like it's sort of probably about 75% done. So and everything's worked out pretty much as I expected. Now there are some errors, and I'm not going to show you those now. There are things that can be fixed. For example, just said I wasn't going to show you, but I am. Space on either side of the steel spaces doesn't seem to be equal. I don't know why. I need to go through and check my dimensions. At the end of the day, it's not going to affect how it works. and I've got an issue down the bottom here. I pre-drilled some holes to attach the headstock to this plate, and I think they're not aligned properly, but again, something that can be fixed. Alright, so I think we're getting close, and I'm really enjoying this build, and I can tell you now this thing is starting to get heavy, so it's going to be fun lifting this on the back of the milling machine. Alright, thank you very much for watching today. I'm going to leave you with some wildlife and also a weather event that we had recently. We got 110 millimeters of rain in about 3 hours, and it led to some pretty spectacular overland flows, is what they call it. The good thing about living here is that you can have these sort of massive flows of water over the surface of the ground, and then within 24 hours it's all gone, strained away, and things are starting to look a lot better. But at the time, it always looks spectacular when you look out the window and see these streams that appear out of nowhere. Okay, thanks again. I'll see you next time. It's Prezzo signing out for now. Cheers. This is a baby scrub turkey. These things are a little bit bigger than a chicken, and when they're born they never get to meet their parents. So the eggs are looked after by the male, and he incubates the eggs in a big pile of mulch, which composts and gives off heat. And he leaves, he absconds from the scene just before the eggs hatch. So the eggs hatch, the little chicks come out, and they just take off. So their defense is that they can run really fast. Got the whole gang here today. Fergie mound is made right next to the stairs over here at Noosa Heads. And this guy's just kicking the dirt everywhere.